All right, my name is Todd Leuty. I work with the Ontario Ministry of Agriculture, Food and Rural Affairs, and working with the maple syrup producer industries and research component. Today we're going to be talking about the different parameters of grading maple syrup and qualities of maple syrup. And it's important to understand how some of the assessment of quality and grading works for producers. And if you are entering your syrup in a competition, just to understand what some of the parameters that the judges will be looking at to measure and determine how well syrup has been made and filtered and color classified and all of those things. I want to look at color, how color is classified. The international color classification, also how clarity is determined in the finished syrup, and also look at a bit on density, also measured to make sure that producers are understanding how to process syrup to the right density, or to more precise, getting the density perfect to improve the quality even more. So I want to start off with color, and we all are using the international color classification system. A grade A, first of all, the grade is grade A, and we have the four color classes within the grade A grade, and that's golden and amber, dark and very dark, and some of the different tools we use for measuring color. I think the color comparator is probably the most commonly used one, and we can see the different grades here: the golden, the amber, and dark. And anything darker than dark would be classified as very dark. But these represent the darkest color of each grade. So if your syrup, if you put your sample in there, you can kind of move it around and find out where your syrup fits in these color classes. There's other ways that you can measure color in syrup. It's, for example, the Lovibond wheel is used, but it's a kind of a pricey unit. Some of the inspectors might be using the Lovibond, but the color comparator is the most often used. Should be replaced every 2 years because the colors can change or go off grade. So every 2 years you should replace that. And next, talk about the clarity of maple syrup. And clarity is done to determine how well the syrup producer has filtered their syrup, basically. And it takes a bit of practice, I found. I've been judging syrup now for about 8 years. The clarity I find is best when you have a number of samples, you can compare them. So when you're looking at syrup, you're looking through it, I often will bring something in print, fine print with maybe a graph or something to hold it behind the syrup, and you can see the clarity of the print behind the syrup. Gives you a good idea of how clear it's been filtered. Is there any sediment on the bottom? There's a bit of sediment on this one. What I found over the years is when I look at the inner surface of the glass, especially down near the bottom, when the syrup is really well filtered, the clarity of that inner surface becomes very sharp. So I've got another sample here of it's labeled, but if you look down at the bottom here, the inner surface of the glass, it really sharpens when the filtering has been done really well. So it's some people are also able to determine ropiness. If you can see ropiness in the syrup inside, sometimes you can see like a swirling effect or the layering effect in the syrup just by kind of doing that. But when you do have syrup samples to compare in a judging competition, or with your neighboring syrup producers, if you want to have your own little comparisons between syrups, I find that when you're able to do that, it's a kind of a confidence builder when you do see a really clear, sharp, well-filtered syrup. And the next, I'll talk about density. And density is important. Like the food inspectors, they look at density, but also the industry has a base requirement for density of 66 degrees Brix in Ontario. And a little bit higher than that will give you a more precise or a better quality flavor or a mouthfeel in the syrup. So 66.5 degrees Brix. it's often, it's kind of sad when you're judging competitions when a producer has entered in the competition and they're disqualified because they're under density, so below 66.0. If you are kind of riding the line of what's legal and not legal on the density, it's better to push it up higher. Especially if you're going into a competition, push it up quite a few notches above 66 degrees 0 to make sure you know you're at least in the legal range of maple syrup. Because if you don't reach that 66 degrees Brix, all you can do is call it concentrated sap. You're not allowed to call it syrup at that point. So the density is important, and the different tools you can use to measure density. I know in some states and provinces they will use the hydrotherm, hydrometer. Hydrometer is probably more common and reliable here as in Vermont. But if you want to see how to use the instrument, Vermont has an excellent YouTube video. University of Vermont, I should say, has an excellent YouTube video on how to measure the density. A lot of producers still have the handheld refractometer. Just by putting a drop of syrup on there on a clean surface, you can measure the density of syrup. But again, we won't go into too much detail. As long as you're confident in the equipment you're using, if you're not confident or not sure that the equipment is measuring accurately, compare with some of your neighboring syrup producers. Compare with the density readings they're getting, or take it to the local extension office. They often have equipment you can compare. There's also a few labs you could send your samples to have comparisons made with the density that they measure in the lab compared to what the equipment that you are using. But for judging competitions now, we're getting more to rely on the electronic digital density readers. They can be very precise. This is a Misco reader. It's what I use here. But there are other brands. There's a Tego. There's another one. A few other density readers. They are very accurate, but you still need to know how to use them. So you need the instructions. You need to read the instructions on how to not to calibrate them, but how to use them, how to zero set them. They're precision instruments, but you still need to tell them what zero is. They don't know what 0 degrees Brix is. So that's when the distilled water comes in handy. You need a good supply of distilled water and a little dropper to put it on there with. The first thing you should do though is wash your hands when you're going to zero set or calibrate one of these units. Wash your hands, because if any sugary residue gets onto that little prism reader, it could throw off your zero set. So wash your hands and then wash the lens really good with distilled water, and then set it to 0 using distilled water so that it knows what the density of all your syrup samples are going to be. Another important thing that we use is Acer puts out a product. It's a concentrated solution that's exactly, in this case, exactly 66.0 degrees Brix, and you can use it to clarify or you get some assurance that you have an accurate zero set. After you've set it to 0, put a drop of this on and it should read exactly 66.0, and then you'll know that the unit is in good shape and ready to go for evaluating the samples of syrup in the competition. And we've also gotten into the practice of actually using 2 of them, because when you get similar readings on both machines, your confidence goes up in the actual reading of the density. So people who are entering competitions also have to have confidence in how the judging is done. So you have to be trusting of the judges and how they're measuring these different parameters. And we're just finding that having two units that say the same thing on each sample, it gives you pretty reliable and confidence in the densities you're actually measuring in a competition. It's quick and it's fairly clean. It's pretty standard now, I think, for most of the larger competitions. And even more of the syrup producers themselves are getting into buying the digital units too.